Good morning, guys. So, what I want to do today is I want to start out with what we were talking about yesterday and drawing these angles in radians, okay? So, I want to grab this point right here because we have an angle. This would be the initial side right here along the positive x-axis, and this pink side right here is the terminal side, okay? All right, so I want to count by, I actually have too much selected there, okay? I want to start by counting by angle by pi, okay? So this would be 0 pi, this would be pi, 2 pi, right? As I've gone all the way around, you see the entire arc, right, around the circle, that's 2 pi radians, okay? This would be pi radians. You can also see right here, okay, that would be pi radians, 1 pi radian, okay? All right, so that'd be pi right to right there, 2 pi, if we keep going around, 3 pi, 4 pi, 5 pi, 6 pi, 7 pi, and so on, okay? So if I back up, okay, and I go the opposite direction, I go this way, okay, then this would be negative pi, negative 2 pi, negative 3 pi, negative 4 pi, negative 5 pi, negative 6 pi, and so on, okay? All right, now pi over 2's, okay? So I want to create this angle from 0 to pi, and I want to break it 0 to pi, and I want to break it into two equal angles, right? So that'd be this one right here, and then this one right here. Okay, so we're going to stop it right there. So this would be 0 pi out of 2. This would be pi over 2, 2 pi over 2, but nobody's ever going to say 2 pi over 2, okay? And then 3 pi over 2, and then 4 pi over 2. But 4 pi over 2 is really 2 pi, okay? Keep going, that'd be 5 pi over 2, 6 pi over 2, but that's really 3 pi, 7 pi over 2, 8 pi over 2, but that's really 4 pi, 9 pi over 2, and we can keep going that way, all right? Okay, so let's do the reverse, okay? Let's go clockwise, okay? So this would be so we're going to break here to here into two parts, right? And so this would be negative pi over 2, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2. Nobody's ever going to say negative 4 pi over 2. They're going to say negative 2 pi. They're always going to give it to you in the simplified form. And then negative 5 pi over 2, okay, and so on. We could just keep going around and around and around, all right? Okay, so then how about pi over 4's? Okay, so that means I want to break the angle from 0 to 180 degrees into 4 equal pieces, right? So I'd create one of them right about there, second one right there. So this would be pi over 4. This would be 2 pi over 4, 3 pi over 4, 4 pi over 4, and then I could keep going, okay? Because this would be 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4, and I could keep going around and around, okay? Pi over 6's, okay? So pi over 6. Pi over 6, I'd want to break 0 to pi into 6 equal angles. Each one would therefore have to be 30 degrees, okay? So this would be pi over 6, 2 pi over 6, but nobody's ever going to say 2 pi over 6 because 2 pi over 6 reduces, okay? 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 12 pi over 6, no, I'm sorry, 11 pi over 6, 11 pi over 6, and then 12 pi over 6, okay? All right. If we went in a negative rotation, this would be negative pi over 6, negative 2 pi over 6, negative 3 pi over 6, negative 4 pi over 6, negative 5 pi over 6, negative 6 pi over 6, negative 7 pi over 6, negative 8 pi over 6, negative 9 pi over 6, negative 10 pi over 6, negative 11 pi over 6, and then negative right there back, negative 12 pi over 6, okay? All right, so hopefully you're getting the hang of this, okay? All right, Let's go by pi over 3s. Okay, so that now what I want to do is break the angle 0 to 180 degrees into 3 equal pieces, or I want to break pi into 3 equal pieces. Each one would be pi over 3. Okay, so the first angle would be right about in here, the second angle would be right about in here, and the third angle would land on pi right here. Okay, so this would be pi over 3, then this would have to be 2 pi over 3, 3 pi over 3, right there, and then 3 pi over 3 is pi, okay, and then 4 pi over 3 would be right about here, 5 pi over 3, and then 6 pi over 3 would take us back, okay, to where we started at, all right, because 6 pi over 3 is 2 pi, which is a full rotation, okay. We could keep going, and this would be 7 pi over 3, and then this would be 8 pi over 3, and then this would be 9 pi over 3, but 9 pi over 3 reduces to 3 pi, okay? And 3 pi should be landing right here on the negative x-axis, okay? All right, this is going to be really important. This isn't just a one day and done. Like, we're going to be doing this whole unit, okay? So this is really important you get this, okay? Really important, because you're not going to be able to evaluate trig functions without understanding this, okay? So what if we rotate with a negative angle? That's why I'm spending time on this with you guys, okay? And not just, oh, here, this is it, and that's it. All right, we're done, okay? No, we're going to be doing this all unit long, okay? This is really important for calculus, okay? So right here, this would be negative pi over 3 if we're going in the negative direction. And then this would be negative 2 pi over 3, okay? And then negative 3 pi over 3, and then negative 4 pi over 3, negative 5 pi over 3, and then negative 6 pi over 3. And we're back to where we started, because negative 6 pi over 3 is negative 2 pi. Okay? All right, so really you just have to know how to do these with pi over 2, pi over 4, pi over 3, and pi over 6. Okay? So you have to be able to count these with a denominator of 6, a 3, a 4, a 2, and then count by pi's. Probably pi's is the easiest one. Okay? All right, so next we'll start the lesson, okay? So today is April 16th, and what we're going to be talking about is arc length and sector area. And before we get into it, I want to talk about converting between degrees and degrees decimal and degrees minutes seconds. And we're going to talk about that in just a second, all right? But before we do that, I want to look at this units, okay? This is a length, okay? 3 yards, 1 foot, 6 inches. That's the length of something, and it's using 3 different length measurements, right? 3 different units, yards, feet, and also inches. So the basic idea of this is we want to be able to switch this into just one unit, either just inches or just yards. And I'm going to show you what we're going to do is that this is equivalent to, okay, 3 yards, 1 foot, and we start to work on converting, okay? So the 6 inches, well, 6 inches is really how many feet? And it'd be half a foot, or 0.5 feet, okay? So we'd have, and you know what, and we don't put this in between here, but it's actually addition in here, okay? So 3 yards plus 1 foot plus 0.5 feet, because this 6 inches is the 0.5 feet, okay? So now we can combine these because we have the same unit. So we actually have 1.5 feet. So now this is 3 yards plus 1.5 feet. And we've converted it down to just 2 units now, right? Well, what do we know about 1.5 feet? Well, a yard is 3 feet. So 1.5 feet would be half of that, right? So we have half of a yard right here. So this becomes 3 yards plus 0.5 yards. Okay, so what that means is this 3 yards, 1 foot, 6 inches breaks down into one single unit of 3.5 yards. Yards. I can't spell yards. So 3.5 yards, all right? Okay, so 3 yards, 1 foot, 6 inches is the same as 3.5 yards, okay? This would be equivalent to doing degrees, minutes, seconds as an angle, and this is just as a decimal, okay, 3.5 yards. All right, so let's get into this. What is this minutes, seconds thing, okay? So 1 degree, okay, and this is the degree symbol, all right, is equivalent to 60 minutes. So if you take one degree of angle and you break it into 60 pieces, that would be, each one of those pieces would be 1 minute, okay? All right, so this little apostrophe right here, it looks like an apostrophe, that's the symbol for minute, okay? Now, if we take one of these minutes and break that into 60 equal pieces, then that would be seconds, okay? And it's just like the time unit, okay? So 60 seconds makes 1 minute of angle, okay? So right here, this double arc right here is, or double arc, the double apostrophe here is seconds, okay? Now, we're going to do this with a calculator, right? And because there's a way to do it by hand, but it's just not worth the time spent on doing this. So I'm going to show you how to do it with a calculator. If you don't have a calculator, it's going to be okay. Just, and this is not hinged on you have to be able to do this to do the next math class, okay? It's not at all. So if you skip these problems on the homework, if I give them to you, I just want you to have an awareness of this, all right? What I really is important is, can you find the arc length in the sector area, okay? This is just kind of a side little thing right now, okay? All right, so I'm gonna slide this up a little bit, okay? And let's talk about how we're gonna let the calculator convert, okay? So you type into the calculator, okay, 63.7375 degree minutes seconds, okay? And then this is the buttons you'll need to push. You'll press second, apps, and then select number 4, DMS, which stands for changing, this arrow stands for changing it to degree minutes seconds, okay? So I'm gonna go to the calculator and I'm gonna show you how to do that. All right, from our calculator, we're gonna type in 63.7375, okay? And then we're gonna press second apps. If you're looking at your notes, okay, we're gonna press second apps. So apps is right here, okay? So second apps, because second apps gives us this blue, the second feature, which is angle, okay? And then we're going to select number 4, which is this DMS. This arrow represents change to degree minute seconds. So we're going to select that one. So you just press 4 and then press enter. Okay, so this angle, 63.7375 degrees, converted to degree minute seconds, is 63 degrees, 44 minutes, 15 seconds. Okay, and so we would just write that on our paper. So I'm going to go back to our paper and we'll write that. So on our paper, let's write 63.7375 degrees is equivalent to, so we want to write equals 63 degrees, 44 minutes, 15 seconds. And minutes and seconds and all this is used a lot in like navigation for ships and even planes, okay? So this is used in navigation a lot, all right? Let's go to the next one, okay? How do we go in reverse? How do we take something that's in degree minute seconds and convert it to decimal? And so you're seeing a picture of it right here, okay? But what you need to do is enter the number of degrees into the calculator, all right? And then press second apps and select number 1, because you got to put in the degree symbol, all right? And then you got to put in the minute symbol. And then you got to put in the second symbol, okay? And there's no place, you can't put a double apostrophe, you can't put apostrophe twice to get the seconds, all right? There's another one that's in your calculator that I'll show you where it's at, okay? To enter the seconds, you'll have to press second, and that's the second feature in your calculator, and you'll push plus, okay? So if you look at that, you'll see right above the plus button that there's a double apostrophe there, okay? All right? And then we'll press enter. So let me go back to the calculator and we'll put this one in. So for this one, we're going to type in 234, 234, and then we need the degree symbol. So to get the degree symbol, we're going to press second apps, and then it's number 1. And then we have 49 minutes, so we want to type 49. And the minute symbol, we have to press second and apps for the angle menu. Okay, and we're going to select number 2. Okay, so now we have minutes. Now you can't do 2 of these to mean seconds, okay? That doesn't work, all right? So then how many seconds do we have? We have 12 seconds, right? So 12, we're going to type in 12. And then to get the seconds, okay, here it is right here. It's in green, right? Okay, so you know what? On the notes it says second, but really you need to press alpha because it's green right here. Okay, you see me circling it? Okay, so we need to press alpha and then the plus sign, and there's where we have our seconds, our symbol for seconds, okay? And then all you have to do is press enter, and it will convert this degrees, minutes, seconds into degree decimal, okay? And just press enter, and there we have it. So 234 degrees, 49 minutes, 12 seconds is equivalent to 234.82 degrees, okay? So we'll go back and we'll write that on our paper, okay? So for this one, we know that 234 degrees, 49 minutes, 12 seconds is equivalent to 234.82 degrees. Okay. All right. So the next thing I want to do is just do these 2 examples. Okay. And I'm going to do both on the calculator at once, and then we'll write them down, and then we'll be done with this part of the lesson. Okay. Okay, so for that first problem, what we want to do is we want to type in 251, or first example, I should say, not problem, 251.8175.8175, and then we want to convert that to degree decimal, or not degree decimal, degree minutes seconds, okay? So we want to press, to get this angle menu, we want to press second, apps, and then we want to select number 4, which will convert it to degree minutes seconds. So number 4. And there we have that one. Okay, so 251.8175 degrees is 251 degrees, 49 minutes, 3 seconds. Okay, and then we want to convert the next one, for example, 2. We want to convert 47 degrees, 32 minutes, 42 seconds to degree decimals. So we're going to type in 47 and then second and then angle to get the degree symbol, which is number 1. And then we want to type in 32. And then again, we want to press second angle to get the minutes, which is number 2. Okay, and then it's 42 seconds, so 42. And then again, to get the seconds, we have to use this right here. This is the seconds units right here. So we're going to press alpha because it's in green, and then plus, and there's seconds. Press enter, and 47.545 degrees. Okay, so we'll go back to our paper and we'll record these. All right, so from our calculator, we know that from this that 251.8175 degrees is equivalent to 251 degrees, 49 minutes, and 3 seconds. And then 47 degrees, 32 minutes, 42 seconds is equivalent to 47.545 degrees. And I should have written this one first. So 47 degrees, 32 minutes, 42 seconds. Okay. All right. Again, if you don't have a graphing calculator that will do this, don't worry about it. Okay. This is just something I wanted to show you that might help you in future math or science classes. Okay. All right. So let's go move on to the arc length and sector area. Okay. Okay, so we're going to talk about arc length and area of a sector. And the arc length is a part of the entire circumference, okay? So this would be the arc length right here, this dark one. I'm going to color it in red, okay? Just so we have a different color, okay? So that's red, okay? All right, so what we need to do to get this is we need to know the circumference of the circle, okay? And the circumference of a circle is the distance all the way around. So we need to know, I'm going to cover up the circle right now with my hand, okay? That the circumference is always equal to 2 pi r. And that's from, 7th grade math, 8th grade math, and even math 2, okay? All right. Now, for this, okay, the area of the sector, okay, the sector is a part of the area of the entire circle. So what we're going to need is to get what is the, we need to know what's the area of a circle. So the area of a circle is equal to pi r squared. And these are very similar in the way you do them. And I want you to understand that whether, and even if it's degrees or radians, it's really done the same way. Okay. It's just whether you're using the circumference formula or the area formula. Okay. So what it is we need to know this angle right here. Okay. Because what we have here is a part of the entire circle, and the angle that is required for the entire circle we know is 360 degrees. In degrees it's 360 degrees. In radians it's 2 pi. Okay, so we need to know this angle right here to either find the arc length or the sector area. Okay, so this is how you find it. Okay, so the arc length in degrees is equal to, okay, so what you have is you have this angle theta out of the entire 360. So that's the fraction of the circle you have. So you have theta out of 360 degrees times, okay, and what you have a part of is the entire circumference. So this would be theta out of 360 times the circumference, which would be 2 pi r. Okay, so this right here, this theta out of the 360 is the part of the circle that you have. It's how much of this entire circle you have. Okay, and then this 2 pi r right here, okay, that's the circumference of a circle. Okay, for the area of the sector, this gray area, right? How much area do you have there? Okay, it's really done the same way. Okay, so the area of a sector, the idea is the same. Okay, so the area of the sector is equivalent to, okay, so you have theta out of the entire circle, rotation of the circle, which is 360 degrees. So this would be theta out of 360 degrees times, okay, and then what it is you have part of the entire area of the circle, right? And the entire area of the circle is pi r squared. So this is theta out of 360 times pi r squared, okay? Once again, this theta out of 360 degrees is the part of the circle that you have. And the pi over squared, or not pi over r squared, pi r squared, sorry, I can't talk today. All right, pi r squared is the area of the circle. Okay, and that's how you would do it in degrees. And you were supposed to have learned this in math too, but I think sometimes we get behind in math too, and we don't quite have a chance to go over this with you guys. Okay, all right, so this is arc length and this is the area of a sector if the angle is in degrees. It actually, okay, this is where, like, you may have been wondering, like, why is radians, why do we use radians, why don't we just keep using degrees? It turns out that a lot of the formulas are a lot easier if you switch to radians. Okay, so this is kind of a semi, not that complicated, but a little complicated formula. You're going to see when we switch to radians and we do the same thing in radians, things are going to clean up really nicely. Okay, all right, so let me slide down and we'll do this the same idea, but we're going to use radians, okay, instead of degrees. Okay, so I'm going to try to keep us seeing this. Okay, all right. So if we were measuring it in radians, okay, then the arc length would equal, okay, so it's no longer going to be the whole entire angle for the circle is 360. Instead, it's going to be 2 pi. So it's still going to be this theta out of 2 pi. Okay, so theta out of 2 pi. times, okay, so that's what this is that's the part of the circle you have. You have theta out of 2 pi, and our angle theta is now in radians, okay, instead of degrees, okay? So we're going to do theta over 2 pi times the circumference of the circle, which is 2 pi r. So once again, this right here is the part of the circle, and this right here is the circumference of the circle. Okay, now notice what happens here. Theta over 2 pi times 2 pi r. Your 2 pi's are going to cancel. So in radians, the arc length simply becomes theta times r. And that's all you have to do. If your arc length is in radians, it's just the angle times the radius. That's all it is, because these 2 pi's cancel. So it becomes this very simplistic formula, you see? So that's the benefit of switching angles into radians and understanding and using everything in radians. As a matter of fact, when you get to calculus, all right, there's a thing called derivatives. And if we try to do derivatives with angles that are measured in degrees, they are really, really complicated formulas that we don't need to use, because they're very simple formulas if we have our angles in radians, okay? So it's very beneficial to have our angles in radians, okay? And that's why this was developed, okay? Now back over here to radians for the area of the sector, okay? It's going to be the same idea. The area of the sector would equal, okay, instead of theta out of 360, again, it's in radians, so it's going to be theta out of 2 pi, okay, and then times pi r squared, okay? Again, this is the part of the circle, and this is the area of the circle. Okay, and so what happens here in this case is now 2 pi is not going to cancel. It's just going to be your pi's that cancel, and so you're left with an area of the sector, which is theta r squared out of 2, okay, or over 2, okay? Or some people will write this 1/2 theta r squared, okay? This one's probably a little bit easier to work with if we do it this way, okay? All right, so arc length is theta r in radians, and area of sector is 1/2 theta r squared. Now I'm going to tell you something, okay? What's more powerful, if you memorize this, you're going to forget it. And if you memorize this, you're going to forget it. What I'd rather you do is understand the concept, and it doesn't matter if I give it to you in degrees or radians, you can still do it. Because what's the idea? What do you see in all four of these? It's the part of the circle times the circumference, or the part of the circle times the area of the circle. So you see that idea in both, okay? It's just, it simplifies if you're in radians, okay? So you're gonna see me do this and not have this memorized, okay? Yeah, if you memorize it, great, okay? But I know that's just a trick. It's a quick and easy fix to get answers right, but you lose the idea of it. When you go right to this without understanding this, then what happens is this is easily forgettable, okay? And all of a sudden you don't know it for the next class, okay? You do need this for future calculus classes. You need to be able to do arc length, and you also need to do the area of the sector, especially if you get into higher level math, okay? They do calculus with all of this stuff, okay? All right, so let's turn the page and let's start doing a couple of examples. Okay, so for example 3, I want us to here's a circle, okay, and I want to be able to find the arc length, and the arc length is this darkened part of the circle right here, okay? Do you see how it's kind of more bold than this side? So that's going to be the arc length that I want to try to find, plus I've been given this angle right here, okay? And then I also want to find the area of the sector. So let's start with arc length, okay? So what do we know about arc length, okay? So arc length. Well, what do we know? Well, we know that we're going to take and we're in radians because this is 7 pi over 6 because there's no degree symbol on this, okay? So we know we're in radians. So we know that's going to be theta out of 2 pi times the what's the length all the way around the circle, okay? And that would be 2 pi r. Okay, so I know from this that, and this is what I mean is by, I don't want you to memorize the formula. I want you to understand like where it comes from. Okay, so this 2 pi's, your 2 pi's cancel. So you're left with theta, or I can do it over here, theta times r, right? Which allows me to go, okay, so what's my theta? My theta is 7 pi over 6. Let me erase this theta that I was starting to write here. Okay, so our theta is 7 pi over 6. So 7 pi over 6 times the radius, and the radius right here is 11 kilometers. Okay, so when we multiply this, that would give us 77 pi over 6 kilometers. And that would be the length of this. So if you took like a string or something and you lined it along this, okay, and then you straightened it out, that's how long it would be, okay? And so we want to put this into our calculator, okay? I'm not going to go to the calculator to do that. I already have it right here in front of me, okay? But it'd be 40.317. And that would be kilometers also, okay? All right, how about arc length, okay? So not arc length, we just did arc length, all right? Sector, okay? So the area of the sector. Okay, so the area of the sector would be this area in here that I'm trying to kind of shade in a little bit for you so you can see. It'd be all of this shaded region right in here, okay? All right, so how do you find area of the sector? Well, once again, it'd be the angle theta, and because we're in radians, it's out of 2 pi, and then times the area of the entire circle, okay? Because remember, this is going to give us the part of the circle, and so theta over 2 pi times pi r squared. Our pi's cancel, okay? And we're left with theta over 2 times r squared, or 1/2 theta r squared. Okay, so now let's put everything in. So this is equal to 1/2 times my angle, which is 7 pi over 6, times my radius squared. My radius was 11, so this would be 11 squared, okay? So putting 11 squared would be 121, okay? And then times 7 would be 847. So this would be 847 pi over 12, because 2 times 6 is 12. And the units on this would be square units, okay? So this would be kilometers squared. Now this is the exact area, okay? We would put this into our calculator and we just type in 847 pi divided by 12. And that would give me a decimal approximation of 221.744 kilometers squared, okay? And that's it for example number 3. Okay, for example number 4, again, we want to find the arc length and the area of the sector, but this time I haven't given you the diagram. I've just given you the information. The radius is 9 feet and the angle theta is 7 pi over 4, okay? So let's find the arc length first. Okay, and what do we know about arc length? Well, it's going to be a part of the circumference, okay? So it's going to be theta out of, and it's theta out of 360 or theta out of 2 pi. Well, our angle's in radians, so it's out of 2 pi, because that's the same as 360 degrees, times, okay, the circumference of the circle, which is 2 pi r. Our 2 pi's cancel. We're left with theta times r, okay? So then our angle is 7 pi over 4. And we're going to multiply that by our radius, which is 9 feet, okay? And then that would give us an answer of 63 pi over 4 feet. Now, why is it feet? Because our radius was measured in feet. Okay. Now, putting that in our calculator, we just type in 63 pi divided by 4. Okay. And that would give us an approximate value of 49.48 feet. Okay. Moving on to the area of the sector. Okay. Area of a sector is, again, theta out of 2 pi times the area of the circle, pi r squared. Our pi's would cancel, and this would be theta over 2, which is equivalent to 1/2 theta times r squared. Okay, so this would be 1/2 times our angle theta, which is 7 pi over 4, times our radius, which is 9 squared. Okay, then that would give us a value of 567. You could put this, I expect you to put this in your calculator, okay? So 9 squared, which is 81 times 7, that gives you 567. Pi over, and then 2 times the 4, right, would be 8. And that would be feet squared because it's area, so it has to be square units, okay? And then putting this into our calculator, that would give us an approximate value of 222.66 feet squared. Okay, and that's how you find the length of an arc, or the arc length, and the area of the sector, okay, for parts of circles. All right, so I have an assignment for you. I'll pull out the assignment sheet, and then we'll get, I'll tell you what I want you to do. All right. Okay, so on your assignment sheet, what I want you to do is worksheet TF3, okay, and that's for 16. Okay, that's when I'm going to assign it. Okay, and I'm going to give you. I'm not going to make things due on the weekend on Saturdays or Sundays. Okay, so today's lesson, I'm going to give you. I always give 2 days of school for you to complete it. Okay, so today is Thursday. All right, so I will give you till Monday at midnight to turn this in. Okay, so Monday would be the second day of school, okay, from Thursday. All right, so that's how I'm going to do it. I'm always going to give you 48 hours or so, actually normally more than 48 hours to complete the assignments. Okay, and that just gives you can do this on your own time. You can watch the videos. All right, please be completing the notes. And when you submit your lessons, they're going to be worth 8 points. It's going to be 4 points for the notes, and then 4 points for completing the homework assignment. Okay, I know it's not really a homework assignment anymore. Everything's homework, okay, because everything's being done in the home. All right, but yeah, I'm going to give you 4 points for each. So make sure you're showing me that you're completing the notes. Okay, that's a big part of it. That's the easy part. All right, you guys take care, and I will. Well, I guess I won't see you tomorrow, but we'll have another lesson tomorrow. Okay, you guys take care. Bye.